Hello students, welcome to the second session of the set. Let's recapitulate it what we have done in the previous session. We have done introduction of sets, we have done roster form, set builder form. We have discussed about the type and what is set and how the set can be represented in the roster form and how the set can be represented in a set builder form, and even the changes in a roster form into a set builder form and set builder form to roster form. These all things we have discussed in a previous session. Now in this session we will discuss about types of set. Now in type of sets we will first come to the empty set. What is this empty set? Let's analyze the certain statements. Here the first statement says, let A is equal to X is such that X is greater than 1 and less than 2 and X is a natural number. When we talk about the natural number, we know it very well. It starts from 1, 2, 3, 4, 5, 6 and so on, and there is no natural number between the two consecutive natural number, isn't it? So when we are not having any natural number in this, so here we will have no element. So no element means, does it mean that we will write it 0? Will it be? No. We will not write 0. This will be not the correct representation of the set, but it will be termed as phi, or it will be termed as a empty braces. Now here further we say that another statement says X is such that X belongs to natural number and X is less than 5 and X is greater than 7. So if we list the element X is less than 5, so we will have the elements, that is your 1, 2, 3, 4. These will be the elements, and further the elements will be here, that will be your 8, 9 and so on. So here if we see that the X elements are not being satisfied, whether it is X is less than 5 and X is greater than 5. So we cannot have the value of this X which satisfies, which is either smaller than 5 or greater than 7. So again we will not have any element, and this will be also represented as phi or with empty braces, isn't it? And in the third one, the C part, that is X is such that X is an even prime number greater than 2. So when we are talking about the even prime number greater than 2, and we know it very well, prime numbers start from 2, 3, 5, 7 and so on. We don't have any other even prime number other than 2, isn't it? So 2 is the only even prime number and there is no other prime number. So again we will have no element, and this will be also represented as this phi or empty braces. So here we can define this empty set, that a set which does not contain any element is called empty set, or it will be called as the null set or void set, and it will be denoted by this Greek letter phi and or with the empty braces. One thing you need to keep in mind is that if we are writing this set, say that is if I am writing it like this empty braces and this contains 0, so this will not be called as an empty set. This will be a wrong presentation. If we write phi inside the braces, then this will be also a wrong presentation. The representation of the set, the empty set will be only defined or represented by this phi or empty braces. These two are the correct way to define it. Clear? And if there is any element present in the set, so it will not be called as an empty set, but it will be called as a non-empty set. Now we move to another set, type of a set, which is known as the singleton set. Now when we are talking about the singleton set, by the how this will be a singleton set, we see here that is set with having 0 as the element, with set which is having a -8 as the element, and if we talk about this, that the x is such that x belongs to natural number and x square is equal to 4. When we are just talking for the 4, this will become your, that is 2. So x is, if we are taking out the square root of 2 or the square root of 4, so we will get value of 2, or the square of 2 you will get it as 4. But if we say that x is such that x belongs to integer, x is equal to 4, then we will have this kind of set. So in the singleton set, we'll say that the set contains exactly one element is called singleton set. You see there, and here we have two elements in this set, -2 and 2. So then this will not be called as a singleton set. Clear? Okay, now further we move to more statements through which we will be defining, or we will find out what kind of the representation this set is given, and we are talking about which type of set. Now here we say let A is equal to 2, 4, 6, 8, 10 and 12. Now here we see that the number of elements we can count it. So here set A is equal to 6, and this can be represented as n, this is the one, and A is equal to 6. This is known as the cardinal number. Cardinal of set A is equal to 6. Cardinal means that when we count the number of elements of the set, so this is known as the cardinal of set A is equal to 6. Now let's say another, that let B is equal to set of all letters in English alphabet. So when we are talking about all the letters in English alphabet, so what number of the elements are there? We know it very well that in English alphabet that we are having 26 numbers of letters. So we can represent this cardinal of B is equal to 26. Now the set of all points on the arc of a circle. So when we are talking about all the points, and if we draw a circle and if we consider an arc, this is a circle, and if we consider the arc from here to here, so how many points will be there? Can we count it? Can anybody count the number of points, that how many points will form this much of arc? You cannot count it, isn't it? Now we see further, that is, this statement says कि 5x is such that x belongs to z positive. That means कि positive integer. And if we are writing down the element of this set, so what we will have? This we will have 5, 10, 15, 20 and so on, isn't it? So we can, our counting will finish it off. No, our counting will not finish it off. Now here we say another one, x is such that x belongs to natural number and x is less than 1. Now here we see that this statement, when we are try to write down any element, we don't get any element in this. So now here from first statement to fifth statement, what we have analyzed, here we can count it, isn't it? Here we can count it, here we cannot count it, and here also we cannot count it, and here also we can count it. Now this is about that we say this is your finite set, this is your finite set, this is your finite set, and here it will become infinite set, and this will become infinite set, and this will become your empty set. So now if you see that we are talking about other type of set which is known as the finite and infinite sets. We are talking about the finite and infinite set. We say an empty set or non-empty set. Empty set, which you have seen the last set was what? That was empty set, isn't it? There was no element. And here the empty set or non-empty set in which process of counting of elements come to, then element surely comes to an end, is called finite set. So if that where we are not able to end the counting, we were not able to end the counting in the third part as well as in your fourth part. We were not able to end the counting. So these two will be termed as infinite set, and the fifth one will be taken as a finite set because now it is clear. Now further we move to the more different types of sets. Yeah. Okay. Now we take up the another set which is known as the equal set. Before we go to the definition of it, we try to analyze the statements. Now here it says A is equal to x is such that x is equal to 2n and n belongs to natural number and n is greater than equal to 1 and less than equal to 5. So when having n, so we will write it down, that is your 2, 4, 6, 8 and 10. So these elements will. Now we analyze this one. So b is equal to x is such that x belongs to even number and x is less than equal to 10. So here if we list the number, so we get it as 2, 4, 6, 8 and 10. Now here if we see the set A and set B, both are having the number of elements as well as the elements are same. So when these two sets are having the same number of elements as well as all the elements are equal, then we say A and B are the equal set, and we will represent it A is equal to B. Now let's see the another one. The P is equal to x is such that x is a prime number less than 6, less than 6. So here we will have the prime number, that is 2, 3 and 5, isn't it? And this says x is such that x is prime factors of 30. So when we are talking about the prime factors of 30, so we will have 2, 3 and 5. Here also, so here we see that P and Q both are having the same number of elements as well as the elements are also same. So here also we will write it down, P is equal to Q. Now it says this statement or this definition of this equal set says that two sets A and B are said to be equal if they have exactly the same elements. So in both the sets, if we see that in the part 1 and part 2, that we are having both the sets are having the same number of elements and these elements are also same, exactly same, then we write it A is equal to B. And if we have the set where the number of elements are differing or the elements are not same, then we say A is not equal to B, then the two sets will not be considered as a equal set. Now what will happen if we have the case, say A is 1, 2, 3 and B is 2, 4, 6. Now here if we say that both the sets are having the number of elements are same, but we are not having all the elements are same. So here these two sets will be considered as A is equivalent to B, and these two sets will be known as equivalent, and here the cardinal number of A will be equal to cardinal number of B. So here the number of elements present in A will be equal to number of elements present in B. So they both will be termed as equivalent set. And here P, in the case of C, this P is having 1, 3, 5 and Q is having A, E, I. Here also that P will be equivalent to Q. So these will be the equivalent set. In this session we have done first your empty set, second we have done singleton set, third finite set and infinite set, fourth we have done equal set, and fifth we have done equivalent set, isn't it? Now let's discuss the certain question of exercise 1.2 about which the concept I have explained you here. Now first question says which of the following are examples of null set. That means it is talking about the empty set, the first set we have done it. So there you will be listing the elements first, and if the elements cannot be listed, so that your set will be your null set. Now second says which of the following sets are finite or infinite set. So here the countable numbers will be your finite and uncountable numbers will be your infinite set. In the third question says state whether the following sets is finite or infinite. So here you will read down the statements. It says a set of lines which are parallel to x-axis. So these kinds of the statements, then you have to find it out whether they are finite or infinite. Fourth says state in the following state whether A is equal to B or not. So how you will find out? The equal, that exactly all the elements should be same of the two set. So you need to compare it and then you have to write down the answer. Here the fifth one says are the following pairs of sets equal? Give reasons. So here you have to give reason why it is a equal or why it is not equal. Okay. So this you will be listing. Here you have got already in the roster form. This you will convert in the roster form and find it out whether you are having the same elements or not. And same is here. And the last one, from the sets given below, select the equal set. Now here you have to find out which two sets or three sets which are equal, all the elements are same. I hope this thing is clear. You will do this exercise and submit me on the next day. Clear?